Hello and welcome to Lesson 4, Graphical Analysis. In this video, we're going to be working through Example 2, Part A. Now, Part A is asking us to interpret a velocity time graph, and it wants us to find the acceleration of whatever object this is being represented in this graph. Now, along the y-axis, we have velocity, and it gave it to us in sort of unique units. This is saying that this is going to be in units of 10 to the 2 meters per second. So we could say if this is our 1 value, this is actually like 100 meters per second. Okay, so we're going to keep that in mind as we work through this problem. Now, I want to quickly also go over the unit analysis for this graph. So if we say that the slope of this line is rise over run, right? We're going to say that our y-axis, our rise, the units are meters per second. The run here is what we're going to divide it, rise over run. So we're going to divide this by the units seconds. If you work that out, it equals meters per second squared. So you can see these are the same units, meters per second squared, as acceleration. So the slope of this line should in fact work out to acceleration. Great. Well, what do we do now? I didn't put in any values here. That's for you to interpret on your own graph. But I did point out 2 little dots that I'm going to use to find the slope of this. When I read this graph, I interpreted these dots to be at about 2. So that'll be 2 seconds and about 2.7 in the y value. So really that's going to be 270 meters per second, right? Because we're going to multiply by 10 to the 2. And down here, right at the end of the graph, I used another value, 40 seconds and 0.5 in the y value. So that works out to actually 50 meters per second. All right, so if we want to find the slope of this line now, all we do is we use the same old formula that we've been using the whole time. Right, slope is equal to y2 minus y1 divided by x2 minus x1. Great. We can plug some real values into here. We can say that, something you might not be comfortable with right away. But you see how our slope is moving down? This is a negative slope. If you've taken math, you're probably a little bit comfortable with negative slopes. Typically what we see in graphs is we're used to seeing positive slopes, right? They're going to be moving up this way. Not in this case. So it's okay that we are running into a negative value here. I'm just going to back that off. Okay, so we're going to use this as our y2. So 0.5. 0.5 minus 2.7 divided by 40 minus 2. All right, this works out to negative 2.2 divided by 38. Okay, but something that you might not notice or might not be picking up on is that we have to come back to this, our y value. Our y value is actually still in this 10 to the 2. So I'm going to add that in now. I'm going to say this is 2.2. Extend this line out, times 10 to the exponent 2. And I'm going to put all that in brackets just so it stays together. Good. Now, if we plug this into our calculator, it's going to give us our slope. So we're going to say that our slope is equal to, what do I get? I get a value of 5.8 meters per second squared. Negative 5.8. I almost missed my own point there. All right. If we want to interpret our sig figs, it's not the easiest in this because we're interpreting a graph, but I could read the graph to about 1, maybe 2 sig figs. I'm going to keep my answer with 2. All right. I'll put a box around this to indicate it's my final answer, and we'll call that good.